So here we have a basic situation where we have a spaceship, a 1,850 kilogram spaceship starting at a speed that we don't know, and it's going to travel 40 meters and use a force of 3.4 times 10 to the 5 newtons in order to go faster, reaching a speed of 165 meters per second. But what we want to find out is what speed did it start at. So we're going to use energies to solve this type of question. Now, there's a couple ways you can do it, but we're going to use energies. Now, the thing about energies and how they connect to each other, of course, is work is equal to the change in kinetic energy. So if you have the kinetic energy and the work, you can find out what kinetic energy it started at or ended up with, or the work. It's all about adding and subtracting energies. So let's see what kind of energies we can find. Now, we don't know the first kinetic energy because we don't know the first speed, but we can find out the kinetic energy at the end since we have the mass and the final speed. So I find out my kinetic energy at the end, or EK2. If I do 1/2 mv2 squared, I can calculate that my spaceship ended with approximately 2.52 times 10 to the 7 joules of kinetic energy. Now, it got some of that energy from the work done as it was speeding up. So find out the work that was done. I've got distance and I've got force. So if I just do work is equal to force times distance, I can see how much work it did and how much kinetic energy it gained. So if I do work equals FD, I can calculate that it gained approximately 1.36 times 10 to the 7 joules of kinetic energy. So it started at a kinetic energy I don't know. It gained 1.36 to the 7, ending up at 2.52 to the 7. So to find out how much kinetic energy it started with, I can just take how much it ended up with and subtract how much it gained when it was speeding up. So over here, my first kinetic energy would then be my final kinetic energy, take away how much work was done, which leaves me with approximately 1.16 times 10 to the 7 joules of kinetic energy. Now this, of course, is equal to 1/2 mv squared. So this has to be equal to 1/2 mv1 squared. So I have the kinetic energy it started with, 1.16 to the 7. I know the mass of my spaceship is 1,850. I can put them into the expression and then solve for V1. And if I do that, I get a V1 of approximately 112 meters per second. So that's how fast approximately it was going at the beginning.